day, everyone. Welcome to our presentation on assignment 3. Before we start our presentation, here are my group members.
For the next 15 minutes, we will discuss topic 3 about comparative static analysis. So if you are interested in this topic, please stay tuned. For your information, the first problem is about the explicit form of the national income model, and there are 3 variables which are Y star, C star, and T star are endogenous variables. C now, I now, G now, and T now are exogenous variables, and B and T are parameters. So now we will need to determine and comment on the effect of change in G now on Y star, C star, and T star. We are going to use reduced form to find the value of endogenous variables which are Y star, T star, and C star. First, we substitute the consumption function into income function. Well, the disposal income equal to Y minus T to obtain the Y star, which is C now minus BT now plus I now plus G now over 1 minus B plus BT. Next, we will substitute the Y star into the text function to obtain T star, which is T now minus BT now plus TC now plus TI now plus TG now over 1 minus B plus BT. Lastly, we substitute Y star and T star into the consumption function to obtain C star, which is C now plus BI now plus BG now minus BT now minus BT I now minus BTG now over 1 minus B plus BT.
Now, let's move to the next one, is to determine and comment on the effect of changes in exogenous variable, which is G now on Y star, C star, and T star. First, we need to do partial derivative to determine the effect of changes in G now on Y star. Since the answers obtained for equilibrium level of income is in the form of fraction, so we need to use quotient rule to do partial derivative of Y star with respect to G now, which to obtain the answer whether the relationship between Y star and G now is a positive or negative relationship. As a result, the answer we obtain between Y star and G now is a positive relationship. This means that when the government expenditure increases, the equilibrium level of income will increase by 1 over 1 minus B plus BT and vice versa.
Next, we also need to use quotient rule to obtain the partial derivative of C star with respect to G now, which to obtain the answer whether the relationship between C star and G now is a positive or negative relationship. As a result, the relationship between C star and G now is a positive relationship, which means when the government expenditure increases, the equilibrium level of consumption will increases by B minus BT over 1 minus B plus BT and vice versa. Lastly, by using quotient rule to obtain the partial derivative of T star with respect to G now, which to obtain the answer whether the relationship between T star and G now is a positive or negative relationship. As a result, the relationship between T star and G now is a positive relationship, which means when the government expenditure increases, the equilibrium level of taxation will increases by T over 1 minus B plus BT and vice versa.
For your information, the second problem is about the general implicit form of the ISLM model, and we need to determine and comment the effect of change in signal on Y star and I star. First step, we need to find the total differentials of both equations by letting exogenous variable C null not equal to 0, where M null equal to 0, because we just need to focus on C null. So for the first equation will be written same as before, but we just remove the M null from the parentheses, which become F1 parenthesis Y star I star C null identical to Y star minus C null minus C parenthesis Y star I star equal to 0. And for the second equation, we remove the m null from the parentheses, and the equation which become F2 parenthesis y star I star C null identical to L parenthesis y star I star equal to 0. Next, there are two ways to find the total differentials. For the first way is delta F1 over delta y dy plus delta F1 over delta I di plus delta F1 over delta C null d C null equal to 0 for the first equation, and delta F2 over delta y dy plus delta F2 over delta I di equal to 0 for the second equation. The second way is add alphabet D on both sides of each equation, which become d bracket y star minus C null minus C parenthesis y star I star equal to d bracket 0, and d bracket L parenthesis y star I star equal to d bracket 0. Then expand the alphabet D into the equation, which become dy minus C subscript y dy minus C subscript I di minus d C null equal to 0, and L subscript y dy plus L subscript I di equal to 0. You guys can choose either way to find the total differentials.
Second step, we need to rewrite the total differential which we obtained in A into matrix form, which is Jx equal to B. First, we need to rearrange endogenous variables on the left-hand side and the exogenous variable on the right-hand side. For the first way, the first equation has one exogenous variable, so we move it to the right, which becomes delta F1 over delta y dy plus delta F1 over delta I di equal to negative delta F1 over delta C null d C null. And the second equation retained as same, which is delta F2 over delta y dy plus delta F2 over delta I di equal to 0. So for the second way, we also do the same thing, which is the first equation become bracket 1 minus C subscript y dy minus C subscript I di equal to d C null. And second equation also retained as same, which is L subscript y dy plus L subscript I di equal to 0. Next, we just transform the equation into matrix form, which is Jx equal to B. First way is insert the two functions into matrix J, which are delta F1 over delta y, delta F1 over delta I, delta F2 over delta y, and delta F2 over delta I. Vector x is endogenous variable, which are dy and di. And B is inserted after the equal sign. Since the exogenous variable has negative sign, so we need to put the delta F1 over delta C null in the parentheses and d C null just put it outside. After that, we can obtain the answer from A, where matrix J for J11 equal to 1 minus C subscript y, J12 equal to negative C subscript I, J21 equal to L subscript y, and J22 equal to L subscript I. Vector x is dy and di, and B is 1 and 0. Second way is to directly transform the two functions into matrix form, so the answer obtained is the same as the first way.
Third step, we need to find the determinant J. So we just multiply opposite A, so the answer is L subscript I times 1 minus C subscript y plus L subscript y times C subscript I. Since the problem has given the restriction, then we just use positive or negative sign to evaluate the answer. For L subscript I is less than 0, so it is a negative sign. C subscript y is in between 0 and 1, so 1 minus any number between the interval will always positive. L subscript y is more than 0, then it will always positive, and C subscript I, so it will always be negative. Therefore, the answer we obtain is negative, which is not equal to 0, means that it is non-singular.
For the last step is to determine and comment the effect of changes in C null on Y star and I star. So for the metric form, we need to divide it by the C null at vector x and the b. Then the metric form will become J11 equal 1 minus C subscript y, J12 equal minus C subscript I, J21 equal L subscript y. and J22 equal L subscript I. Vector X is dy star over dc now and di star over dc now, and V is 1 and 0. Next, we will use Cramer rules to see how the effect of changes in C now on Y star. So, determinant J1 become 1 minus C subscript I, 0, and L subscript I. Then we want to see the effect of changes in C now and Y star equal to the determinant J1 over determinant J. Then it will become L subscript I over L subscript I bracket 1 minus C subscript Y bracket plus L subscript Y C subscript I, where the problem has stated the restriction, so L subscript I will be negative and the determinant J is negative. So the answer we obtain is positive, which is greater than 0. Therefore, when the autonomous consumption increases, the equilibrium level of income will increase by L subscript I over L subscript I bracket 1 minus C subscript Y bracket plus L subscript Y C subscript I, and vice versa.
Lastly, we also will use Cramer's rule to see how the effect of changes in C null on I star. So determinant J2 become 1 minus C subscript Y, 1, L subscript Y, and 0. Then we want to see the effect of changes in C null on I star equal to determinant J2 over determinant J. Then it will become L subscript Y over L subscript I parenthesis 1 minus C subscript Y parenthesis plus L subscript Y C subscript I, where the problem has stated the restriction, so L subscript Y will be positive and multiplied with negative sign, and the determinant J is negative. So the answer we obtain is positive, which is greater than 0. Therefore, when the autonomous consumption increases, the equilibrium level of interest rate increases by L subscript Y over L subscript I parenthesis 1 minus C subscript Y parenthesis plus L subscript Y C subscript I, and vice versa.
Thank you for your time for watching our video, and don't forget to subscribe, like, and share.